All right, R-Chain governance, voting in Rolang. Dan Connolly and collaborators for fall 2020. So this is work in progress. There's Patches welcome. Got a number of collaborators here. In particular, feedback on either these slides, they're open for comment, or issue 69 in the RV 2020 is welcome. Okay, so a number of you have tried the beta version of the voting application, and when you're ready, it says to sign and submit your response in Rolang. My what? So what exactly am I signing here? And are my answers really equal to all this Rolang? Okay, so the first line of the Rolang is the rev address from. That's you. Your registered address with the co-op. And then there's one revlet, 0.0001 rev, a little bit of dust, as they say. Then these other rev addresses, each one corresponds to one of the choices you made. And there's some code in here that does rev transfers. It finds or creates the vault corresponding to the rev addresses. It gets a deployer auth key, which is a witness that the transaction signature matches the rev from address, and it does a transfer. It does one transaction for each of your answers, in parallel, no less. And so you can imagine the results look, sort of like this in a spreadsheet. You've got the voter addresses in one column and their choices in another column. The amounts are sort of immaterial, they're all one. And you can pivot this around and you can find out that 10 people voted yes on question 1 and 2 people abstained and so on. Everybody following me so far? Anyone following me so far?
I'm following.
All right, great. Okay, and I would expect a certain amount of the audience is content with that much explanation. If you've seen enough already, that's fine. Again, feedback is welcome. But suppose you actually wanted to know more. You're not convinced yet that this represents your vote. I'm going to give you a crash course in the row calculus. Row calculus has 6 building blocks. We can put processes in parallel. We've got a process called nil, which is. And we can, this purple bar with a vertical block lets us take 2 processes and put them in parallel. And we can do that again to get 3 processes in parallel and so on and so on. Okay, then we have these interesting star and at blocks. And the at block allows us to take a process, nil, and make it into a name, at nil. Then we can take the star to turn that back into a process, star at nil, and make that into a name, at star at nil, and so on ad nauseum. Not only that, but since we made a process, star at nil, we could put that one in parallel with something else, nil. And then now we have nil in parallel with star at nil. We can make a name out of the whole thing by putting an at in front of that. And so on and so on. Okay, then the interesting one of the more interesting parts of row calculus is the bit where you send and receive to make communication. Okay, the third block is the send block with the exclamation point. The bit between the parentheses is a process, and the bit on the other side of the exclamation point is a name. So here we have nil in parallel with star at nil. We're sending that to at nil. Then the receive block is the second block. The process goes between the curly braces, and names go between the parens. So I've got a process nil in parallel with, and I'm going to wave my hands just a little bit. I'll leave a blank there. And we're receiving on at nil, and the name we're receiving at again. I'm waving my hands just a little bit. So something interesting happens when you put these send and receive in parallel if the names correspond. The name that you're sending to and the name you're receiving from are the same name, and you put these in parallel, you get communication. And what happens is, I'm going to actually show this more clearly. So we have our send block at the top and our receive block at the bottom. And what happens when these two get together is that the receive part goes like this, and the part that was sent gets filled in like that, and this part goes away. And that's what happens in row calculus communication. Did that make sense, Daryl, or anybody?
Makes sense to me.
All right. So that's row calculus communication. And that is your crash course in row calculus. There are 6 blocks. There's 5 ways to make processes, 1 way to make names. So I think this is pretty interesting. The whole thing fits on the front side of a t-shirt. This is what got a lot of people into RChain, is that the architecture comes down to this really simple yet powerful row calculus. All right. All right, so Rowlang is row calculus plus this and that and the other thing. So let's just pause for a moment to look at the blocks on the top and the characters on the bottom, and boy, they look similar, don't they? All right. So yeah, so the vertical bar, sometimes we put things side by side and sometimes we put them above each other. It doesn't really matter that much. All right, so one of the wrinkles in Rowlang is this new X and P notation. We observed earlier that the row calculus provides for an infinity of names. There was and so on and so on and so on. So this new construct, what you do is you choose one name, one of those infinity of names that does not occur in any other Rowlang expression that was ever written down or ever will be written down. So this it's hence unforgeable. No one else can write it down. And you say, well, let's let X stand for that name in P. And that allows us to take this text at the top of the screen with this great big, you know, infinity of names name, and then just call it X at the bottom. But otherwise, it's the same thing. All right, and in the row calculus, we had nil as a basic building block that you can make a process without any other processes to build it from. In Rowlang, we've also got int, string, bool, and URI. Expressions are processes too. So URI is like HTTPS or row colon. And there's some system processes. We'll talk about those in a little bit. And there's other ways to build up processes out of processes, tuple, list, map, and set. There's an idiom for win or lose using true and false in the first part of a tuple. You might say size 1, color blue, and so on. One interesting thing is you can have the set 1, 2, and then 3 in parallel with the list 4. So the data structures are pretty rich. All right, there's I'm not going to tell the whole story of Rowlang. That'll be for another day. But I will observe that there's a syntax called contract, CXY equals P, and it's short for a persistent receive. We showed you the receive block earlier. There's another wrinkle on that where you have a less than equals instead of less than dash, and it means keep receiving over and over and over. Also, we only showed in row calculus just P1 sent to X, but it's actually polyadic, so you can do P1, P2, P3 sent to X. Likewise, you can receive on multiple, and there's a match construct where you match some process with pattern 1 and so on. All right, so full story on Rowlangs for another day, but back to voting. All right, so this is the same, the code on the right is going to be the same all the time. I just made parts of it bigger and smaller. So we got this system process. Earlier, we observed that you can have URIs as processes, and then you can quote them to make names. And this new construct allows you to get your hands on it. So one of the system processes is row RChain deploy ID. So it corresponds to the deploy signature. Each deploy's got its own signature. So this deploy ID is a conventional place to put the results of a deploy. Maybe the success in case all the transactions went through, or failure in case there was, a rev vault couldn't be found or something. And this deploy ID is unforgeable. It can't be expressed in any other deploy. So folks familiar with other programming languages have seen function calls. The way one writes a function call in Rowlang, at least Rowlang 1.0, is you choose a new name, as we discussed, or also known as a channel. Choose a new channel, rev vault in this case, on which to receive the result of the function call. You send the arguments in the return channel to our RL function. RL is short for row registry lookup here. And you receive the results back on the return channel. We receive them back on this RevVault channel, and we're going to pattern match out just the part we're interested in here. The second half of the tuple, we're going to bind that to RevVault. So that's function calls in Rolang. In Rolang 1.1, the syntax is considerably more concise. Looking forward to that. Okay, so one of the things we can do with our function calls is registry lookup. We're going to send a target URI in the return channel to RL, and we'll return the value back from the registry for use in the body of the for language, so that for comprehension. So there's the open, close curly braces, and we get to use RevVault all throughout there because we bound it here. So that's registry lookup. The RevVault API, it's got a few little nuts and bolts to it. Earlier we talked about the deploy ID. There's a thing called deployer ID that's only visible to the signer of this deploy. So all of the deploys signed with the same key get the same deployer ID, but anyway, who doesn't have that key can't express this deployer ID. They wouldn't have it unless I sent it to them. So we're going to use the RevVault find or create method, sometimes a function call with a string as a first argument. I'm going to call a method call. We use the find or create method to look up a RevVault by its address. We're going to do that for the to vault only to make sure that the vault exists. We're not actually going to send any messages to the to vault. The deployer auth key method gives us a key provided we have the right deployer ID. This is going to check that the sending address corresponds to the signer of this deploy, this transaction here. And the transfer method, finally, once we have the vault that we're sending from and the to and the amount and our key, then we can actually execute the transfer, and the results come back on this return channel. So that's the RevVault API. And then just putting it all together, we get the RevVault and list ops from the registry. We get the sender's vault and their key. And then for each of the to addresses, we send a little teeny bit of rev, 10 to the minus 8. And we send the results of this deploy back to the off-chain part of the dApp. And that is the whole thing. And I hope I've convinced you that this represents your response when voting in Rolang.